For decades, the idea that Mars once hosted vast oceans was a popular but highly debated theory. Some scientists rejected the notion entirely, viewing the evidence as mere indirect observations or artifacts of poor image resolution. But today, everything has changed. NASA has uncovered a groundbreaking discovery, a massive subsurface reserve of liquid water on Mars. This hidden reservoir is huge enough to flood the entire planet with a mile-deep ocean, finally resolving the long-debated topic of whether the red planet still harbors liquid water. However, while we now know where the water is, a massive problem remains for future exploration. In this video, we are diving deep into the latest data. How did a planet that was once Earth-like, with a thick atmosphere and a warmer climate, transform into a freezing, barren desert? And if this water is still there, why can't we reach it? Join us as we explore the rivers, lakes, and oceans of Mars. For years, the hunt for water focused on the surface. We knew Mars had frozen water in its polar ice caps, but that wasn't nearly enough to account for the planet's ancient history of massive floods and valley networks. The mystery sparked a new line of inquiry. Where did the rest of the water go? The answer came from NASA's InSight lander, a mission designed to study the internal structure of Mars rather than its surface details. During its 4-year mission in the Elysium Planitia region, InSight recorded over 1,300 Mars quakes. These tremors, caused by meteor impacts and volcanic activity, generated seismic waves that geophysicists use to analyze the planet's interior. By studying how these waves moved through the Martian crust, a technique similar to how geologists on Earth map oil fields and aquifers, scientists found something shocking.
If you enjoy deep-dive science documentaries like this, focused on real data, real mysteries, and the edges of human knowledge, consider subscribing. New videos explore the universe where certainty ends and discovery begins. And let us know in the comments what you think. Thanks for watching.
The seismic data revealed a layer of fractured igneous rock located between 7 and 12 miles, or 11.5 to 20 kilometers, beneath the surface. These cracks and pores are filled with liquid water. The volume of this groundwater is staggering. Based on the seismic data, researchers believe there is enough water stored in these deep aquifers to cover the entire surface of Mars in an ocean approximately a mile deep. This discovery, published in August 2024 by scientists Vishon Wright, Matthias Morsfeld, and Michael Manga, suggests that Mars didn't just lose its water to space, it absorbed much of it into its crust. But here is the big problem. Accessing this water would be an enormous challenge. To reach it, future astronauts or colonists would need advanced technology capable of drilling miles beneath the Martian surface. Currently, such a feat is far beyond our reach, presenting a major obstacle to those hoping to use this water for life support or fuel. While InSight looked deep into the planet, China's Zhurong rover was busy exploring the surface of Utopia Planitia, the largest known impact basin in the solar system. This region was long suspected to be an ancient ocean basin, but proof remained elusive until recently. Using its ground-penetrating radar, Zhurong detected something that had never been seen on the ground before. The rover encountered 76 geological reflectors that all sloped in the same direction at angles between 6 and 20 degrees. After comparing this data to buried beaches on Earth, such as the Bay of Bengal, the team realized they were looking at a coastal foreshore environment. This is a dynamic part of a shoreline where sediment is deposited by tides and waves. These sloping layers suggest that Mars once had standing bodies of water that existed for an extended period. We even know that the Sun and Mars's larger moon Phobos would have affected the surface gravity, potentially causing tides on this ancient Martian ocean.
Finding a shoreline is critical because these environments are the best place to hunt for signs of alien life. Shorelines concentrate organic molecules through evaporation and provide energy sources like UV radiation and chemical gradients that can drive the chemistry needed for life to arise. While Zhurong explored the lowlands, NASA's Curiosity rover has been climbing the foothills of Mount Sharp inside Gale Crater since 2014. This 3-mile-tall mountain is essentially a massive history book of Mars. Its layers allow scientists to study how Mars evolved from a planet that was more Earth-like to the desert it is today. In early 2023, Curiosity made its most surprising discovery yet in a region called the Marker Band. This area was expected to be dry, as it formed during a period when Martian water was thought to be drying to a trickle. However, Curiosity captured images of rippled rock textures. These ripples were formed billions of years ago by waves on the surface of a shallow lake stirring up sediment at the lake bottom. This is the best evidence of water and waves that we've seen in the entire mission, said Ashwin Vasavada, Curiosity's project scientist. The presence of these ripples in a region thought to be dry tells us that the transition from a wet Mars to a dry Mars wasn't a simple, linear process. It involved complex cycles of weather and climate, much like Earth's. Beyond the ripples, Curiosity has observed the Murray Formation, a 500-foot-high section of rock that suggests rivers once carried sand and silt to a lake, forming deltas. These cycles of filling and evaporation occurred over tens of millions of years, suggesting that ancient Mars maintained a climate that could produce long-lasting surface water. Perseverance and the catastrophic floods of Jezero Crater. Meanwhile, on another part of the planet, the Perseverance rover has been exploring Jezero Crater. This site was chosen because orbital images showed a fan-shaped feature that scientists believed was an ancient river delta. Perseverance's photos of a hill named Kodiak have confirmed this. The imagery shows distinct layers of sediment that could only have been deposited by a river flowing into a lake about 3.7 billion years ago. But the story of Jezero has a violent twist. The rover also found large boulders, some up to 5 feet wide, embedded in the upper layers of the delta. It would have taken a massive high-energy flood to transport rocks that large, floods moving at speeds of up to 106,000 cubic feet of water per second. These flash floods might have been caused by glacial surges or intense rainfall, marking the transition from a habitable environment to the desolate wasteland we see now. Despite all this evidence for liquid water, there is a massive scientific mystery known as the faint young sun paradox. Around 3.5 billion years ago, our sun was about 25% dimmer than it is today, too faint to keep Mars above freezing. So how did Mars stay warm enough to lakes and oceans? There are 3 main theories. Greenhouse gases. Mars's atmosphere might have been loaded with carbon dioxide and water vapor, trapping enough heat to allow liquid water to persist for millions of years. Episodic warming. Major events like volcanic eruptions or asteroid impacts could have released massive amounts of heat, creating long-lived warm spells that melted the ice. Or the frozen ball theory. Some think Mars was mostly a frozen ball, but sudden orbital changes or heating events caused temporary melting that carved the valleys we see today. Currently, none of these models perfectly explain how water remained stable on the surface for so long. Solving this paradox is the key to understanding if Mars was ever truly habitable. The Great Transformation. Why did the water disappear? If Mars was once a world of rivers and oceans, what happened? The turning point was the collapse of its magnetic field around 3 to 4 billion years ago.
Unlike Earth, which is protected by a global magnetic field, Mars lost its shield as its core cooled. Without this protection, the solar wind stripped away the atmosphere, causing the pressure to drop. As the atmosphere thinned, liquid water could no longer exist on the surface. It either evaporated into space, froze into the polar caps, or seeped deep into the crustal aquifers found by InSight. The discovery of a massive reservoir of water has sparked renewed interest in human exploration. If we can reach this water, it could provide life support for future explorers. However, the challenges are significant. Beyond the difficulty of drilling 12 miles down, we have to deal with the 225 million kilometer distance to Mars and the harmful cosmic radiation that would bombard astronauts during the journey. Furthermore, the Martian environment is brutal, with temperatures dropping to minus 125 degrees Celsius and dust storms that can last for months. NASA and other space agencies like the ESA and CNSA are planning future missions, including Mars Sample Return, which could bring rocks back to Earth by the 2030s or 2040s. These samples may finally tell us if life ever emerged in the ancient coastal environments of the Red Planet. Our exploration of the red planet is far from over. With each mission, we uncover new mysteries, and it's likely that what remains unknown today will become common knowledge for the next generation of space enthusiasts. If you enjoyed this deep dive into the waters of Mars, be sure to subscribe to the channel. Your support helps us continue to bring you high-quality content about the wonders of our solar system. And if you're looking for more mind-blowing space facts, check out the video on your screen right now. You won't want to miss it. Thank you for watching.